Hello everybody. So today we're going to be revising conics in the shortest time possible. Now the notes you're seeing here are from JE Brief by Vora Classes. The description will contain a link to that playlist. So do check that out. Now let's get started. So we all know what a circle looks like. To write the equation of a circle we need its radius and its center. This is the general equation of a circle with a center minus j comma minus f and radius root over g square plus f square minus c. So let's take a 3-point form. Basically they give you 3 points, they'll ask you to find the equation of a circle. Like, I guess it's not the full question, but you get the point. So your first option would be to just substitute all these 3 points in this equation, find the value of g, f and c, but that's way too time consuming. So the second option is to join any, like 3 of these points, join them, make 2 lines. So you have 2 lines here. Now you're gonna draw their perpendicular bisectors. Now I'm a horrible artist, my drawing is just bad. So this does not look like the center of the circle, but I promise you this is the center of the circle. Now that you have the center, you can just take the distance from the center to any of the 3 points that were given to you and you'll get the radius. So quick recap: 3 points, join them, form 2 lines, perpendicular bisectors, intersection point is the center. So what happens if they give you the endpoints of the diameter? So when endpoints of the diameter are given, basically what you're going to do is use this formula. If endpoints are x1 comma y1, x2 comma y2, just use this formula to get the equation of the circle. Now next let's jump to intercepts. So if a circle intersects the x-axis at 2 points, the distance between those 2 points is actually the length of the intercept. And same here, this is the length of x-intercept, this is the length of y-intercept. Now the length of x-intercept actually has a formula 2 root g square minus c. Length of y-intercept actually has a formula 2 root f square minus c. Now let's say I consider a circle that's like this. So it's intersecting x-axis at only 1 point. At this, in this case, we can say that the length of intercept is actually 0. So that means g square equals to c. Or if we consider a case where it's kind of like this, then f square equals to c, because I've just equated the length to 0. Right. Now let's move on to chord of a circle. So basically one property for chord of circle that you should know is, so basically AB here is our chord. The length of chord that I am considering is 2x. Now this is the center, this is the center, and now if we drop a perpendicular from center onto this chord, it will be the perpendicular bisector of this chord. So basically this length is x, this length is x, this is the radius, because center from circumference. You can use this to find the length of chord, and it's kind of useful in a lot of questions as well. Let's see a question using that exact concept. 2 circles in the first quadrant of radii r1 and r2 touch the coordinate axis. Each of them cuts off an intercept of 2 units with the line x plus y is equals to 2. Then r1 square plus r2 square minus r1 r2. Right. So let's read the question line by line, and according to that I've made the diagram here. So it says it touches both the axis, which means let's say it intersects x-axis at a point alpha comma 0, y-axis at a point 0 comma beta. Then we can consider that the center is r comma r, because this distance from center to this point, let me just change pen color, from center to this point is r, which makes its y coordinate r, and same for y-axis, which makes its x coordinate r. Now they gave us a line, so basically I'm just going to extend the axis here, and that's the line x plus y equals to 2. Now using the concept that we just learned above, you're going to draw a perpendicular from the chord, which is x plus y equals to 2, and this, so basically they gave us that the length of the chord is 2 units. So basically this will be 1 unit, this will be 1 unit, and you have the radius, which is r again. So using this you need to find the values of both the radiuses and you'll get the answer. Let's move on to parametric points. So if center is 0, 0, parametric points are r cos theta, r sin theta. If center is alpha, beta, then the parametric points are alpha plus r cos theta, beta plus r sin theta. If they give us the diameter endpoint, so if you need to write the parametric for the diameter endpoints, if one end is this, basically for the other end, you're just going to replace cos theta with minus cos theta and sin theta with minus sin theta. As simple as that. Before we move on to the next concept, I actually want to talk about something else. S. So S is basically going to be equal to your circle equation x square plus y square plus 2gx plus 2fy plus c. S11 is going to be, so if you're talking about a point x1 comma y1, then you just substitute that point in the equation. That's going to be S11. So x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. If that is greater than 0, the point lies outside the circle. If that is equal to 0, point lies on the circle. Less than 0, point lies inside the circle. Now let's talk with respect to a line. So if y equals to mx plus c is the line that we are considering, just substitute that in the equation of the curve. You will get a quadratic which is either in the terms of x or y. Now you're going to find the determinant. So if determinant is greater than 0, that means that if this is the circle, it has two solutions, which is a secant. If there is only one solution, you're gonna get d equals to 0, basically a tangent. D greater than 0, less than 0, no solution, a line outside the circle. Now if you want to write tangent equation, then basically C is going to be equal to plus or minus r root 1 plus m square, where m is the slope of the tangent, r is the radius of the circle, and the equation we're referring to is y equals to mx plus c. Now not just for a circle, but for any curve, you can write the tangent equation as s1 equals to 0. Now how to write s1? So I already talked to you about what s is, which is basically the curve equation. When you see x square, you're going to replace it with x1. X will be replaced with x1 plus x by 2. If you see xy, you're going to replace it with xy1 plus yx1 by 2. This is to convert an equation from s to s1. s1 equals to 0 is going to be the tangent equation at point x1 comma y1. Moving on, let's find the equation of normal. For circle, finding the equation of normal is actually pretty easy, mainly because every normal passes through the center. So if they ask you about a normal that is passing through a point x1 comma y1, you already have another point which is the center of the circle. So use 2-point form and find the equation. So the next topic we're going to be talking about is the length of a tangent. Now if we assume an external point P, then then this length PA or this length PB. So we can draw two tangents from an external point onto one circle. Both these lengths are going to be equal and they're going to be equal to root S11. Another point to note here is if we assume that the tangents itself are inclined at an angle to theta, then tan theta is r by root S11. You can easily derive this using trigonometry because this angle is equal to this angle. Moving on, so just like this, if you want to write the equations of PA and PB, so pair of tangents, it's going to be S1 square is equals to S into S11. Chord of contact, which is S1 equals to 0. What is the chord of contact? AB is the chord of contact here. Basically, this is the point of contact. This tangent is touching this circle at point A. This PB the tangent is touching this circle at B. Join these points and you have the chord of contact, which is S1 equals to 0. Chord if midpoint is given. So basically if they give you the midpoint of this chord and they ask you to find the equation and you know the circle's equation, this is how you do it. S1 equals to S11. Director circle. So director circle is the locus of all the points from which you can draw perpendicular tangents on to the circle. So basically same as this, but both these tangents are perpendicular to each other. The locus is x square plus y square is equals to 2r square. Now let's move on to common tangent concept. These circles don't intersect each other. and they have 4 common tangents. 2 of them are direct, these 2 are direct, and these 2 are transverse. So R1 plus R2 is less than C1 C2 here. It's evident from the diagram as well. This is R1 R2, C1 C2 is obviously larger. This so basically they intersect at 2 points, and now you have 2 common tangents, and this is the condition. So mod R1 minus R2 is less than C1 C2 less than R1 plus R2. These circles intersect at 1 point. You have 3 common tangents. R1 plus R2 is C1 C2. This situation you only have 1 common tangent. Mod R1 minus R2 is C1 C2. This situation you have no common tangents. Mod R1 minus R2 is greater than C1 C2. Angle between 2 circles. So what does that mean? If you have 2 circles and they intersect at some point, then the angle between the tangents at that point is going to be the angle between the circles. I'm not even going to attempt to draw the diagram, but you get the gist. Cos 180 minus theta in this case is going to be R1 square plus R2 square minus C1 C2 square by 2 R1 R2. Here C1 C2 is the distance between centers. Condition for orthogonality. R1 square plus R2 square is equals to D square. So orthogonality basically is that the tangents are perpendicular. So theta is 90, cos is going to become 0. Now you can understand how we got the first relation. D here is also C1 C2. But you also get another relation, 2G1 G2 plus 2F1 F2 is C1 plus C2. This is not distance between the centers. This is C1 plus C2 as in the constants that you get at the end of the equation. Now radical axis formula is S11 minus S22 is equals to 0. I personally skipped family of circles because I did not see any PYQs in 24 or 25. But yeah, if you want to do it, you can go ahead.